All right, so it's 9 o'clock, so we're going to go ahead and get started. Thank you, everyone, for joining us today. I'm Courtney Arnell, CEO at Ninja Ag, and we are excited to connect you with one of the industry's leading experts on nutrient management and precision ag technologies, Dr. Josh McGrath. He is the associate professor and extension specialist at the University of Kentucky, and we'll talk about navigating nitrogen prices while maximizing yield. As we all know, nitrogen fertilizer prices are holding steady at near record high levels. So we're excited to hear from Dr. McGrath today on how to effectively manage this challenge with strategies and tools. Dr. McGrath has served as an extension specialist at the University of Kentucky since 2014. Prior to UK, he was at the University of Maryland from 2006 to 2014, where he established an integrated research and extension program focused on developing, teaching, and implementing management strategies or practices and that increase farm efficiency while protecting natural resources. He built his reputation through a robust on-farm applied research program in cooperation with farmers and policymakers. Dr. McGrath received the Agronomic Education and Extension Award in 2019 from the American Society of Agronomy and speaks throughout the US and internationally about nutrient management and soil fertility and environmental stewardship. He has served in leadership roles for both the Agronomy and Soil Science Societies of America and on the editorial boards of multiple journals. This session is recorded and will be available on our YouTube channel. Microphones are muted, so please ensure they stay muted throughout the presentation. There will be a time for Q&A at the end of the webinar. You can also submit questions in the chat or to info@ninjaag.com. Please feel free to continue the conversation after the event on social media by tagging us using @NinjaAgLLC or #NinjaAg. Dr. McGrath, hello and welcome. It's our pleasure to now hand it over to you.
Hi everyone. Thanks for having me. Real excited to be here. Boy, that invitation was, or that introduction was a lot longer than probably my presentation will be. So let me get my presentation up here if I can. Now my computer wants to slow down. All right, here we go. So it's going to take it a second to load up. I started working on this presentation, and typical for me, I started kind of geeking out on what I was digging into, trying to get some more current price data. Your slides tend to get a little bit old and stale, and so I started digging for some current price data, and I started kind of geeking out, and I kind of made a mountain out of a molehill and probably went too far. So I hate to do it, but I'm probably going to be rushing through the first few slides, which is good because the first few slides are on economics. I'm not an economist, so that's always dangerous. So hopefully if I rush, you won't be able to catch all of my mistakes. I always tell my students to stay in their lane, never wander outside of your lane when you're giving a presentation. I'm going to break that rule, and I'm going to get way outside my lane and try and talk a little bit about prices and economics. Because I'm getting a lot of questions here recently about, what's going on with fertilizer prices, and talking to people in industry. There's a lot of factors that are influencing fertilizer prices. Nitrogen, the reason it's going up to some extent is a lot different than why phosphorus or potassium is going up. And so, but I think that, this is probably going to hold at least in the short term because the economy is kind of raging back, and that's one of the things that drives these prices. Because as the economy grows, the demand for energy grows, and nitrogen prices are tied pretty tightly with energy prices. Before I get started, I do need to thank Illinois NREC, the Nutrient Resource Education Council. Basically, their fertilizer checkoff funded some of the data that you'll see here, and the Kentucky Corn Growers Association. And so I want to thank them because without their support, this wouldn't be possible. But jumping into it, so here's nitrogen prices. Illinois has the Ag Marketing Service in Illinois is one of the few places that reports biweekly nitrogen prices for a couple of different sources. What I've shown here is anhydrous. UAN, they reported it as a 28% spread. I think that's a little unfair. And then urea, both anhydrous and urea are sold bulk, but that they include the cost of spreading with the 28% liquid nitrogen because they feel like that's how most of it is sold in Illinois. And so it kind of shows what we know as far as those three sources. Anhydrous is pretty cheap per pound of nitrogen. So our vertical axis here is price in dollars per pound of nitrogen, and then I've got here on the x-axis the date, and I've got the years marked out. And so nitrogen prices, you can see this really rapid increase that started last year. Again, a lot of factors kind of pushing into that, but we're just seeing nitrogen prices really skyrocket here recently. But it's not all-time highs. I pulled out it's nitrogen within a year cycles. So I pulled out and I averaged across that anhydrous, liquid, and urea to get nitrogen prices, and we're holding at around 60 cents a pound of nitrogen right now. Each one of these boxes, whisker kind of diagrams, shows that price for the month of August in that year that's indicated on the horizontal axis. And so we're higher than we were back in 2011, 2012 in August. But if we look at average annual prices, so this is annual prices average for the year, we're of course nowhere near 2008 where we hit all-time nitrogen price highs. I haven't adjusted this for inflation or the current value of the dollar. It would be a little bit different. So this is just kind of a quick assessment. Again, not an economist, but generally, we still haven't reached the prices that we saw even in 2014 for annual prices. But that August price is a little bit disturbing, especially when we consider a lot of people are purchasing bulk fertilizer for next year right now. And throughout the Corn Belt in the United States, a lot of nitrogen still goes down in the fall as anhydrous. So that August price is pretty important. It's also the last month I had full data for, so that's why I picked that month. And so what does this mean? How does price influence our nitrogen rate, and how does nitrogen rate affect our profitability? So this is some data from 47 site years. I'll talk a little bit more about this study towards the end of this presentation of where this data came from. It's a little bit more complicated than this graph shows. I just struck an average quadratic plateau response. So you have this kind of curve below the maximum yield, and then we assume at given once you hit the maximum agronomic optimum nitrogen rate, that yield maximizing nitrogen rate, that yield stays the same. Some people will plot this as a quadratic relationship, but I'm just showing kind of a quadratic plateau. We could talk about that during the Q&A if you want to a little bit, but it's not a huge deal one way or the other. And so this is from our Kentucky and Illinois research. I've only included 47 site years. So these were the site years that sort of behaved, quote unquote, behaved. This research was conducted between 2018 and 2020, and still goes on today. As a matter of fact, we're harvesting corn right now. Not today because of the rain we just got, but we're harvesting this study right now, shelling corn as this presentation is going on. So this is a really big study with a lot of data, and this is the average response. About 200 bushels of corn with a agronomic optimum rate a little bit below 200 pounds per acre of nitrogen. So horizontal axis is nitrogen rate in pounds per acre. Vertical axis is yield in bushels per acre, and this is that agronomic optimum nitrogen rate (AONR), where we maximize the yield. But we want to talk about return on nitrogen investment. So return on nitrogen, I call it RON, is dollars per acre. And all I do is take the price of grain times yield from that previous figure. So I take this previous figure and multiply that yield times price of grain. And then I have the nitrogen rate still on the horizontal axis, but I subtract the nitrogen rate times the price of nitrogen. And so I went back historically through that Illinois Ag Marketing Service data, and I got some grain prices for Kentucky. So now I'm mixing data, but I think Kentucky and Illinois are similar enough. And I looked at August of 2018, August of 2019, August of 2020, and today. Actually, it would have been earlier this week when I grabbed these prices. And then I created a worst case scenario that's kind of a theoretical. But if we look at 2018 August, average grain price in Kentucky was $3.58. This is for yellow number two corn. August 2019 was 397 and August 2020 was 360. When I grabbed these prices, it was 522 um, today. And nitrogen prices averaged across sources was 63 cents. Actually, that would have been the price for urea, I think, 63 cents a pound. Um, in 18, it was 37 cents. And 19, in August, it was 43 cents. And in 2020, it was 37 cents. So you can see that over those 3 years, nitrogen prices were pretty steady. Um, and grain prices generally were pretty steady over that 3 year period. And so we see a really steady relationship of the price ratio of just simply that nitrogen price divided by the grain price. And that's true. If we look historically through all, the last 20, 30 years, that price ratio of nitrogen to grain, even in 2008, stays right around zero point 0.1. Today it's at 0.12, so that's kind of high. And the worst case scenario where I picked the lowest corn prices or the highest and the highest nitrogen price. So kind of August 2020, and then I picked this really high 63 cents for nitrogen prices. That price ratio goes way out of whack, 0.18. But we haven't seen that, to be honest. But I just kind of want to show as bad as it could get because I'm kind of working up to a point here because we talk a lot about the price of nitrogen affecting what the right rate is. We always talk about the economic optimum nitrogen rate. What is that? And we can take that yield data and we can solve that equation and come up with an economic optimum rate that maximizes return on nitrogen. And for each of these 5 scenarios today, that would be 161 pounds of nitrogen with that yield response curve, 165 in 2018, 164 in 2019, 166 in 2020. So we can see, the swing there is only about 5 pounds per acre of nitrogen. And let's be honest, the way we apply nitrogen, plus or minus 5 pounds per acre, do we even know what we're doing? And when we're predicting what the right rate is, if you can get within 50 pounds of what you're right with what rate is required, when you're making the decision at the beginning of the season for something that you know the answer to at the end of the season, if you're within 50 pounds, hats off to you. That's a really good job. And so we see that really price doesn't influence rate that much. In the worst case scenario, it dropped quite a bit here to the right rate being around 150 pounds per acre. And if we look on that return on nitrogen investment, what if I applied at this nitrogen price the agronomic optimum nitrogen rate? What would my return on nitrogen investment, what would my profitability in dollars per acre, just considering grain price and nitrogen price, no land rent, no herbicide, nothing else, just nitrogen price, grain price. So we can kind of isolate that. Today, uh, interesting to note, even with nitrogen prices where they are, even if you were applying the agronomic optimum rate and not the economic optimum rate, you still have the highest return on nitrogen investment of all of those scenarios. So I argue that nitrogen is a cheap investment, and that's generally why we apply more than we need to agronomically or economically. There are studies out there, and I've seen data that says actually the right rate of nitrogen is quite a bit above the economic optimum rate that we determine with yield studies because we don't know what that yield response curve, we don't know what this looks like in any given year. And so I'm going to show some data on that in a minute here. But generally speaking, that return on nitrogen is pretty good, even if we over apply. And we see, that those price ratios have an effect that even at the economic optimum rate, we range from $600 per acre to $900 per acre. But price ratios are steady. Normally, there's only a 5 pound per acre rate swing in what the economic optimum rate is. Maybe a $4 per acre swing in that difference in that profitability between agronomic optimum and economic optimum. So, assuming you know what the agronomic optimum rate is and you apply that, you're only losing, $4 to $8, depending on the year. And so, honestly, we throw our hands up and we fuss about nitrogen prices, and it hurts to write that check for that big bulk order of nitrogen. I get that, but at the end of the day, knowing what the right rate is probably more important, and how much rainfall and dry land production for corn And again, this is for corn, but it's going to apply for other cereal grains where nitrogen's a big input. And again, in Kentucky, we've had really good rain over this time period, and some of those things factor in. But weather and how much rain we get and the timing of that rain is going to have a much larger effect on this economic optimum nitrogen rate and that profitability. But this stochastic risk talks about the uncertainty in what the right rate is. And so this is what I was saying, that there's been some economists and some modelers that try and factor this into their nitrogen recommendation, that my yield this year could be 130, next year it could be 230 bushels per acre. And so that risk is what kind of determines that I should apply more than the economic optimum. Actually, because of that risk of a high yield year, I hedge my bets, and I think even if we don't know this scientifically as farmers or decision makers on farms, implicitly the data indicates that we understand this, because the average nitrogen application rate, according to some research, is at this rate that accounts for the stochastic risk, which is about 30 pounds or so above the economic optimum. So if the economic optimum rate is about 160, research indicates that the right rate to offset that risk in price and yield fluctuation is about 190 pounds per acre. And we see that that's generally what farmers are doing, is they're applying above the agronomic and the economic optimum to offset that risk of falling short in good years. And so the big difference, here it is all boiled down, kind of max to min. The best year was 2020, that green line. There's the optimum rate. The worst case scenario, that's not even a real scenario, there's that optimum rate. And this is the total difference in yield. It's pretty narrow on that yield response curve. And again, this is Kentucky yield response data from some studies we did. So that economic optimum and agronomic optimum yields are usually separated by about 1 bushel per acre, depending on the price of corn. And in the worst case, there was a 3 bushel per acre separation. And so, it's not as big a deal as we make it out to be. But so why do we make it out to be a big deal? Why are people at the university kind of always talking about this price differential and how it influences? If we look in the Corn Belt in the Midwest with their MRTN, the maximum return to nitrogen calculator, they make a big deal, those universities, out of the fact they include economics in their model. Well, I think we need to be a little bit more honest about why it's important. It's not that the price of grain and price of nitrogen have this big influence on what the right rate is. It has a big influence on our economic impact. And so we've got to understand environmental impact. We've got to understand that economics, agronomics, and environment objectives have different nitrogen rates that matter. And this is some data from the University of Maryland. You look at that quadratic yield response curve. That's from, where they did all pre-plant nitrogen and a little bit over 200 pounds per acre, got them about 160 bushels per acre. And that was the economic optimum nitrogen rate. That economic optimum nitrogen rate was 25 pounds per acre less than the yield maximizing rate, 1 bushel difference. But by reducing that nitrogen rate 25 pounds from 230 pounds to get max yield to 205 to get maximum return, they reduced the amount of nitrate in the top meter of the soil post harvest by 17 pounds per acre. And that's pretty significant. So there's off-site impact when we over apply that nitrogen. So if we're applying up here somewhere, we're really in that point where off-site impact is increasing dramatically. That's all well and good, but that's not what I'm here to talk about. I want to talk about management. So what are those strategies that we can do to improve efficiency? Whether our objective is environment, economics, or yield, we can do better. There are methods out there that everyone, I think, can probably improve their average economic returns. And then moving to a proven precision technology can increase those returns $15 to $20 per acre. So now we're not talking about $4 per acre. We're talking about almost $20 per acre if I can do variable rate correctly. So, and that's based on some of my data using variable rate sensor-based algorithms. So overall, uncertainty drives these decisions to apply rates above the absolute economic optimum rate or even agronomic optimum rate. But we need to understand this variability and get more precise. So this difference between accuracy and precision. Accuracy is when I apply the right rate on average across a 4 or 5 year period. If I do research and it says the right rate is 200 pounds per acre on average across 50 site years, in every year that rate is wrong. And so by being more precise in that year and in that field, or even within that field, we can kind of offset that stochastic risk. So we can control uncertainty through management practices that improve nitrogen use efficiency. And if we have consistent NUE, then we have confidence in our rate, we can reduce that rate, and we can improve our ROI. And so we can do that through source, timing, and placement in the context of what our crop rotation is and our crop management system. We've got to keep that in mind because the right source or the right timing or the right placement is different depending on my crop rotation, how I'm managing those crops, and some things along those lines. So, yield provides a solid basis for our rate recommendations. There's been a lot of people that have criticized this recently, but it still is a solid basis. But timing from a management standpoint is the big lever that gives us control over, being able to do better with our nitrogen. And so to be able to leverage timing in a yield prediction, we need to understand the fundamentals of the nitrogen cycle. We need to understand those mechanisms that control when my nitrogen is available, when my crop needs it, and how my management interacts with those soil mechanisms and weather mechanisms. So fertilizer type matters. A lot of times we try and simplify. There's so much interest in adding products to our fertilizer to stabilize it. And I'm not criticizing stabilized nitrogen. It has its place. But if I'm investing $5 to $15 per acre in a product that I add to my fertilizer, then I should reduce my rate $5 to $15 per acre from what it would have been without that product. And I don't think most people are doing that. They think adding that product is going to increase yield. And that's, well, if it does, you were under applying to begin with. Okay. So we need to find that right rate and then think about building out the components of the nitrogen requirement. And yield provides that basis for the right rate. And then we can start thinking about the mechanisms to build out those components. Because at the end of the day, fertilizer nitrogen, this is Stanford's equation. It's what the plant needs minus what the soil gives up for free, divided by the efficiency of the fertilizer source. So if I surface apply urea on a hot day when 50% of it volatilizes, so that E on the bottom of that equation is 0.5, I basically have to multiply my fertilizer rate by 2, right? And so how much does the plant need? How much does the soil give me? And what is the efficiency of my fertilizer? And looking at some data that from Maryland that I had historically, we had these 3 sites. This is really interesting. So we've got these 2 sites that respond kind of normally, have this quadratic relationship. As I apply more nitrogen, yield goes up. But I had this one site where 0 pounds of N got me about 215 bushels per acre, right? And so I can plot that average relationship, and an empirical approach would say the right rate is right here. But a mechanistic approach would say each site had a different nitrogen requirement in that year. So we need to strive towards understanding these mechanisms and using a more mechanistic approach. And so how do we adjust nitrogen management? We can use predictive approaches, and that's historically what these empirical, if I am using MRTN, it's kind of just, if I'm in Illinois, here's the price of grain, here's the price of nitrogen, this is what I'm going to apply. In Kentucky, our rate recommendation is 185 pounds of nitrogen on corn, whether you need it or not. That's our official university recommendation. There are predictive recommendations where you take historic yield and just multiply it by a factor like 1. And then there's people that try and do precision, but with a predictive approach where they have zones that are delineated often by yield. I did some of this early on in my career. It turns out that yield history does not do well at the subfield level. On average, if I'm trying to get a whole field rate recommendation, my yield history is a really strong way to do average ag. But when I go to precision ag, it falls apart because of variability in the field and the relationship between yield and nitrogen response. And so then we move into these reactive approaches. So reacts to a need expressed by the crop, which means it requires a crop to be in the field when we're making that nitrogen decision. But we still need information and interpretation to make a decision. I see a lot of precision ag where they'll go out and map the soil, say apparent electrical conductivity with something like dual EM or Variance, and then they make a nitrogen recommendation. My question always is, where was the interpretation? What was the equation that took EC as a value and converted it to a nitrogen rate? And sometimes that's a little fuzzy. So a reactive approach means going in season because if nitrogen, another advantage is if nitrogen isn't applied, it can't be lost. Also, loss is much lower in season with corn because once corn hits that rapid growth stage, water is moving up, not down. And so you need a plan, that predictive kind of baseline, and then you need to go in season and react to what's happened this year. So one thing to note with this kind of thinking about in season, sometimes people get really worried about having enough to make it, if they get held up and can't get across the crop. Here's some data from Iowa State on corn nitrogen uptake. And even pretty deep in the season at V6, you're at less than 20 pounds per acre uptake on a 200 bushel corn crop. You can get into V9, V10, and you're around 40, 45 pounds per acre of uptake. And so you can put down, if you've got some soil supply early in the season, you put down a little bit of nitrogen and get you deep in the season. 50 pounds in the 2x2 or some other method can get you pretty deep in the season. And that's how we conduct a lot of our research. So, what is side dressing? When I moved to the Midwest, I consider Kentucky the Midwest. Some people won't, I guess, Eastern Midwest. Um, it was surprising how few people side dress. And then the people that did what they called side dress was different from what I called side dressing. So, first of all, when I talk about side dress, I mean about going in there in a standing corn crop at V4 or later. This is our current buggy here at University of Kentucky that we use to do research. This is what we used at the University of Maryland to do research. And here's some other options. A lot of people in the Midwest talk about side dressing. They plant corn and they immediately come in with a knife rig like this and start putting nitrogen down as soon as they plant it, or that corn's pretty early at V2 or something. But I really think that side dressing is getting something in there to get you started, 50 pounds or so, and then coming in after V4. So that's just kind of a point of clarity to define that. Back home where I grew up in Delaware, it's sand, really deep sands. We've side dressed corn since the 50s because you have to on those sandy grounds. So, what are some of the tools we have in season? I just want to make a side note. If any of you are using manure in your system, PSNT, while people don't like to do it, a pre-side dress soil nitrate test, a 12-inch soil sample when the corn is 12 inches tall, is actually the best soil test we have. We think a lot about potassium, phosphorus, and lime for soil testing, but PSNT in a manured system or a system with a lot of organic nitrogen, thinking a heavy vetch cover crop ahead of that corn crop, is a really good test. And so different, locations have different recommendations to go with this, but it's kind of that combination of reactive and predictive. You have a nitrogen plan based on yield, and it says apply 200 pounds per acre of nitrogen. You put down 50 as a starter. You come in at side dress, you're going to put down another 150, but you had that 50 was as manure. So you go in, you take a PSNT, it's over 25 parts per million, and you don't side dress. And so the PSNT is a really strong, kind of threshold if you have this organic nitrogen in there. So that's one tool in season. Low tech, old technology works great. What about tissue testing? People love to tissue test right now. It is exploding. The numbers at the labs are crazy. For nitrogen, it's no good. I'm not going to get into this too deep. Here's some data from a friend of mine, Greg Binford, when he was at Iowa State. Here's small plant nitrogen concentration and relative yield. There is no relationship. Now, he also worked on the post-harvest stalk nitrate, the corn stalk nitrate test, and that's a really good relationship, right? And so you look at this, early season tissue testing in corn does not work for nitrogen management because there's too much fluctuation and during those early growth stages. And then by the time it stabilizes, it's too late to help you. So how do we deal with this variability in the field? So the first thing is split apply. If you're not split applying, you're leaving a lot of opportunity on the table because there's more opportunity for loss. There's more opportunity for early season weather to mess your plant up, some things like that. But we kind of set out this study. It's pretty complicated. This is a picture of us harvesting a field here in Elizabethtown, Kentucky last year. So we have preseason rates that go up to basically 350 pounds per acre of nitrogen. And then that's just pre-plant. And then we have split applied, where we apply one of three starters, 18, 37, or 55, and our total season goes up to 350. And so, we're going to look at this split apply, this total nitrogen rate, and we're going to move and look at like how do those things compare. So I've got 7,000 data points, 64 site years, site rotation, cover crops, irrigation, no irrigation, and this is the average relationship as of last year. 216 pounds of nitrogen gets me 214 bushels. So 216 pounds is the right rate if you're really empirical. If you want to be a little bit mechanistic, take your realistic yield goal. So not what you hope for, but what you know you can get based on previous experience and multiply by one. It gets you pretty close. And we found out that if we have 37 to 55 pounds per acre out there at starter, we can get to V10. Current UK recommendations, remember down there, are 185. So our university recommendations here, in my opinion, aren't great. I hope no one from Kentucky is listening. But this is what all that data looks like. Look down here at our zero rate. Our zero rate, our yields go anywhere from 50 bushels to almost 300 bushels. And so there's a lot of variability in this simple relationship. And so I'm going to move into this kind of last component of my presentation here. I know I'm running a little bit long, but if we look at that Stanford equation, it really talks about yield potential, nitrogen response, and loss. Those are the three things that determine my requirement. And so we've been working on an algorithm, sensor-based algorithm that uses NDVI, developed at Oklahoma State. Um, so I worked with this back east in Maryland using the Virginia Tech algorithm, and there is no algorithm for Kentucky or Illinois, Southern Illinois. And so we're developing one now. We just tested it for the first time this year. And we look and we're predicting yield if I fertilize, green line, yield if I don't fertilize, purple line, taking that difference. So yield, NDVI is where my prediction comes from. What's that difference? And I'm calculating Stanford's equation. And so I come up with this nitrogen rate based on NDVI. So I'm sensing that crop at V6 as I travel across the field, and my nitrogen rate is going up or back down. So my really high yield potential up here, my yield without nitrogen is starting to approach my yield with nitrogen. And so I can start to decrease my nitrogen rate in those parts of the field because I'm getting more from my soil. And down here in this poor ground where I have really low NDVIs, I just don't have that much response. So I don't need as much nitrogen. But then I pour it on right here in that kind of mean or a little bit better than average part of the field. And so this gives me a really specific way. And I can use this on average across the field to just adjust for what's happening this year, or I can use it on the go with my sensors or imagery to kind of come up with this variable rate strategy in the field. The last thing I want to mention is about phosphorus, because phosphorus prices have jumped as well. But what does that have to do with nitrogen? I ran out a quick calculation because I was a little curious myself. We put on a lot of phosphorus in the fall here. And if I'm running DAP out in the fall, right now it's $716 a ton. If I'm running that out in the fall, I'm not getting nitrogen return. So I'm actually spending 78 cents per pound of phosphate. If I take and put my DAP down in the spring, closer to corn planting, I'm getting nitrogen value. Currently, urea is valued at 63 cents per pound of nitrogen. And so my phosphorus is only costing me 53 cents a pound. So at 100 pounds of P2O5 per acre, that's $25 per acre gain in my spring nitrogen bill. And I don't have to worry about volatilization from that surface supply DAP or MAP so much. Now with MAP, because of the different constituencies there, the prices are a little bit closer. But the point here is we also we think about, adding NBPT and nitrification inhibitors and things like that, but making these other management changes. There's no silver bullet. Actually, these things are going to have a much bigger impact. $25 per acre is pretty big. Just moving my DAP application to the spring and then being able to utilize that nitrogen more efficiently. So, in conclusion, I know I've covered a lot. I went fast in a short amount of time, but to do better, we have to take an active approach and use our available diagnostic tools. I'm a big believer in using NDVI in season to kind of make these adjustments across the field or on average for a flat rate for the field. But in lieu of that, I'm going to look at my cropping system, my timing, my placement, my source, and my weather. I'm going to split apply. And even if I'm not using any other technology, if I use a yield-based approach, I know pretty well what that field's going to yield. And I'm going to go in at V6 and put down 75% of my nitrogen. I can look at the weather that's occurred over the past 30 to 40 days, and I have much more information just from watching the weather for 40 days. And I can adjust my nitrogen up or down based on my experience of what that weather early season means to final yield. Now, it may stop raining the day I side dress and never rain again the rest of the season. But if you're applying pre-plant, you have the same risk, but it's actually greater. So timing is everything. Risk that weather will delay a timely application in season is the biggest limitation that producers kind of throw back in this regard. My only answer to that is yes, it is risky, but in season is going to be stronger than even stabilized nitrogen preseason. So invest in equipment and tools to offset that risk. Some products provide a measure of insurance. So here's what some people use. I can only get across corn that's this tall, right? This is what we use, and I can raise that boom up. So this is my height limitation, right? And then this is what one of my farmer cooperators has used in the past. And you'll see I don't have anything fancy here. I just got hydraulic hose hanging from the boom, with a stiff kind of lead. I'm not using any of those fancy wide drops. They're fine, but I just drag hose down the center of the rows. And this old 1994 spray coupe kind of gets the job done. You can see our sensors there on the back. Lastly, I would say with precision management, if you're using zones, question how those zones control nitrogen requirement. We really haven't had very much luck with zones. We are looking at this very hard at using soil along with sensors. We're working on that. Yield-based VRN doesn't work. Consider a reactive approach, but ease into it. Adoption is steep, that adoption curve. How are you splitting your nitrogen now? Do that first for a couple years. Get comfortable with it. Start by looking at maps of your field and thinking about that map versus, or maybe just start with one field and use that local guidance or algorithm. You can't use a generalized global algorithm at this point. Replicated randomized strip trials are valuable to help you confirm. I still work with farmers from my days back in Maryland who have green seeker sensors. And so, here's some data from a farmer. They took and did, average yield with green seeker and the nitrogen rate applied. And so this is one field here, this blue line, and you can see that they got about the same yield, and green seeker called for a lot less nitrogen. Here's another field. This was a field that had a manure history. And so, a lot less nitrogen applied, similar yields. And so they're still doing this every year, 10 years later. And then I would also say that as you move into this, you've got to think about your biases. You can't get rid of them. But if you identify them and think about them, then it can understand how it influences your decision making. Because, when I talk about using variable rate and that strategy of a lower rate here and a lower rate here, sometimes the environmental folks are like, that's great. Let's cap them with what they were doing before. And then the farmers look at that and they go, ooh, I'm not comfortable with that rate here or here. I'm going to cap the bottom side with what I was doing before and just get a little extra in the good ground. And so we've got to think about those biases and understand that if you trust the science, you've got to trust the science. So with that, I hope we've got some time to answer a few questions. There's the CEU code. Hopefully you can scan that and get your CEUs. Courtney, do you want to take the screen away from me? And I'll stop presenting now, unless someone wants me to go back to a specific slide.
Let me see. Can everybody? You can now unmute your mic and also turn on your video if you want. If you have trouble with that, just shoot a chat and I'll try to fix it real quick and see if we can get you to get that turned on. I'll just leave your slide up for now, Josh, in case somebody wants you to go back. Anybody have any questions? Okay, I think I've got one for you, Josh. What is the best way to try to get farmers to go to in-season management?
Yeah, that's a great question, Courtney. Back in about 2009, I gave a presentation for the National No-Till Conference. It wasn't on nitrogen; it was on manure use and no-till. And it's a big conference in the Midwest, and so there's a lot of farmers out this way that don't do in-season nitrogen because, quite frankly, when I look at the data, it always surprises me coming from a sandy soil background. These soils out here are very forgiving, and you can do really well and be very profitable. And honestly, there's not a huge amount of savings from going in season. So I think, the first thing is sometimes I think we're a little disingenuous as researchers, when we try and convince someone to do something, we start right off saying, "Oh, this is going to increase yield. This is going to increase profitability." I'm going to be honest with that person up front, and I'm going to say, "There's a little advantage in yield and profitability in some years, but you're doing okay at $600 an acre versus $605 an acre. You won't notice that much of a difference." So the first thing is I'd say is the person who's trying to educate that client, being really honest and saying that's not why you switch. You switch because it allows you to do in-season management. And to jump back a slide here, and we look at that variability and say, going in season helps me find these site years, right? Over 200 bushels with 0 pounds of nitrogen. So the first thing is having a really honest conversation about why you're switching. On average, it's not going to increase your profitability that much. It's not going to increase your yields that much. It gives you that ability to be precise. And so you can go in with a tool and make a decision based on that big, huge gorilla in the room, which is weather. And so that's it's how I talk about it with the producer, is to talk about why we're doing it. And then also, I think the producers I work with are also really kind of sit up and pay attention when I talk to them about, yeah, we do a lot of hand waving about economic optimum and agronomic optimum nitrogen rate, but a lot of producers really do care about this offsite impact. And you start talking to them, going in season really gives me an ability to reduce that leaching. And we're doing some assessment of that in our research now, but it really helps me to be a smarter farmer is the end game there.
Perfect. That's great. Thank you. And we have another question. I have anticipated my first side dress application to V2, and I've got an extra couple of rows of grain per cob. Do you have experience with those anticipated applications?
Yeah. So talking about, where those yield components are, the rows around the cob. I haven't done that in our nitrogen research, but that's interesting because we've done it in our phosphorus. We've done a lot of variable rate phosphorus research over the last 5 to 6 years. And it's funny, we saw the exact same thing. So phosphorus sets yield potential pretty early when we have a response in a field. It tends to be, in our research, the number of rows around the cob. And it's usually on average about 2 additional rows around the cob when we have a response to phosphorus. That's where it comes from. And so that potential gets set really early in the season. I've talked to some of the crop physiologists about this, and there's actually not a clear understanding of when that occurs, but it's certainly before V6, and some people say before V4. And so that comment right there really points to the importance of kind of understanding soil supply, early season weather, early season stress. And if we look at this figure, if I can get my slide, find that slide. Um, if we look at this figure from Iowa State, really understanding that we don't want to stress that corn. If I'm setting the number of rows around the cob, then this is really where I need to be making sure that I'm not falling short right here, right? That I want to make sure that I have enough to get to when I'm going to side dress. And so our strategy, spoon feeding is the best. I've worked with farmers that under irrigation are growing roughly 300 bushel corn on all of their fields, and they're putting out 7 to 9 shots of nitrogen. I think that's overkill, but I guess the proof is in the pudding. They're growing 300 bushel corn and they're doing it on 180, 190 pounds of nitrogen. That's pretty incredible efficiency. And so a big component of that, I think, is that they all are making sure they have enough nitrogen up front and then spoon feeding with time. And so you just got to make sure that you don't fall short, and recognize that you get a lot of early season nitrogen. Up until V2, the plant lives off of what's in the seed. It's not even digging in the soil nitrogen. And so then between V2 and V4, you want to make sure you have a little bit of nitrogen there to supply that plant with about 20 pounds per acre.
Gotcha. Okay, we have another question here about how, if somebody hasn't tried in season management before, or they don't have a plan in place to help navigate everything that you just talked about, where's a good place for them to start?
Yeah, yeah. The starting point, and everyone's at a different starting point as you move around and you talk to people about that. Like, how do you start moving towards that in season nitrogen? So the first thing is it's a machinery question, right? And so you've got to sit down and talk to them about what kind of capital expenses they're willing to invest in this shift in management, because it's not just changing management that is plug and play. um, you have an equipment consideration, and you need to kind of think about the future and where you want to go. Some people really are concerned about volatilization loss, and they think that, like, something like this is really important, and there are higher clearance versions of that. The data, we're talking about a liquid application system, or, are you talking about dry application system? Because there are high clearance dry product applicators. They tend to be pretty expensive, and I think most farmers aren't going to invest in that. The other thing with moving in season is a lot of nitrogen applications rely on the local co-op or service provider. And so they might have something like this, but many in the Midwest don't, right? And so that equipment, it's first of all, it's something that you probably used to you used to kind of offshore. You used to hire someone to do that application. Now you're going in season. The person you used to hire doesn't have the equipment to go in season, or if they do, it's tied up doing spray applications, and they're not interested in picking up nitrogen business, right? And so now the first thing is you're going to have to invest in some equipment, and you're going to have to invest some time. If you're around here, if you're growing corn, wheat, beans, side dress time hits sometimes right around when you're spraying weed. And so now all of a sudden you're balancing another. So you've got to be really kind of clear on talking about what's your time availability, your schedule. Does this mean you're going to have to hire more labor? And so that's why I'm a big fan of something like this, right? Because I can eat a bunch of acres up if I'm side dressing with, with guidance, with auto steer and RTK. I can cruise and eat up a bunch of acres with a 100 or 120-foot boom, which is quite common back east, side dressing. And so, that may be a lot bigger investment than this or this, but I've got to factor in my labor, and I can have this piece of equipment set up so that I can also do spray applications with it, like fungicide late season and some things like that. And so now I can capitalize it over two operations. So where do I start? I start talking to them about the equipment and the time commitment to do it, and being really honest with them about what that is.